In this case, there is a matrix which is given, students. If there is a 3 cross 3 matrix is given, then what is the value of this equation is the question asked. So first we'll try to find out. In always matrices, you try to establish one pattern. Is it okay? So we'll find out A square, that is equal to A into A. A square will be equal to 1 0 0 0 1 0 A B minus 1 into 1 0 0 0 1 0 and A B minus 1. So when we multiply this, we will end up with what? 1 plus 0 plus 0, 0 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 plus 1 plus 0, 0 plus 0 plus 0, and then 0 plus 0 plus 0, 0 plus 0 plus 0, and 0 plus 0 plus 1. Correct or not? Which means A square is nothing but 1 0 0 0 1 0 0 0 1, which is nothing but an identity matrix. Correct? So I can write here, this can be written equal to now, A square is nothing but, I'll write A square only, plus 2, A to the power 4 can be written as A square into A square, plus I can write A to the power 6 can be written as A square into A square into A square. Now A square is nothing but I, plus 2 into I plus I into I into I. So this is nothing but I plus 2I plus I plus 2I plus. The question given here is to find out plus 4a power 6, right? Plus 4a power 6, 4. Here there will be 4, 5, 6, 7. Okay. So this is nothing but 7 times I. Now if you look by the options, 7I is not there. I can be written as I to the power 4 also I can write, correct or not? But I is nothing but what? What is I? I is nothing but A square. A square is nothing but I. So A square to the power of 4. So 7A to the power 8 is the answer to the question, which corresponds to the option number A. Pretty easy question. Just that we will end up with I. You have to match to the options. This way we can match to the options. I to the power anything is I. I is A square power of 8. It cannot be an odd power. It should always be an even power.